go ahead and get started. So today I'm going to be talking about databases, specifically which one to choose, because there's so many when it comes to choosing a database, whether you're developing a project or working in a team, whatever other technologies you have for your stack, you're almost always going to have a database. If you're going to be storing data, using data, it's got to go somewhere. So just first off, a bit about me. I've got my Bachelor's of Science from Austin Peay State University in Computer Information Systems with a concentration in cybersecurity. I'm currently working on my Master's of Science in Computer Science and Quantitative Methods. And I also work at Austin Peay as a graduate teaching assistant, where I do grading, tutoring. If you go to our social media, a lot of those posts I do. And honestly, anything the department needs, I usually do it. So to break down what we're going to be talking about today, we're going to be mainly focusing on databases. We've got relational databases, non-relational databases. We're going to be looking at the standard query language for relational databases and the relational model that it follows. We're also going to be talking about not only SQL and the non-relational databases. And then I'm also going to be talking about NewSQL, which is a subset of relational databases that have started to see production and implementation over the last few years. And then I'm going to follow up with some of the pros and cons of each database, what they're used for. I'm also going to talk about business cases, what they can be used for, and then we'll finish off with a closing and any questions. So to start off with, what is a database? Sometimes we can think it's this complex thing, there's all this data, but realistically it's just something that stores a collection of data. They came from a need for an easier way to store records and information, as storing records on paper wasn't really cutting it anymore. And as computing technology became more powerful, ways to utilize databases became possible. And the first sort of databases, when we think of like a computer databases, is hierarchical and network models. And these ended up not cutting it as well. So this man right here, Edgar F. Codd, came up with the relational model. And he did this so that data could be organized into tables of similar relation. And the main reasoning behind this is because he wanted ways for people who didn't have as much experience working with hierarchical models and network models. He wanted an easier way to understand data so that people from all different backgrounds could understand it and use it, especially in business. So in the relational model, you have columns which represent attributes, and you have each row is going to be a unique record. And he also helped develop normalization, which is just breaking up, say if you have like one big table, normalization is breaking that up into smaller tables and yeah, getting rid of dependencies and stuff like that. So this is just a quick example of a relational model. So I've got two tables, an employee table and a role table. And the reason we split it up into two tables is so that we don't have redundant data. So instead of having role name and the salary be repeated twice for these two employees, Bob and Courtney, we make a new table that stores that information. And so this is just a fairly simple example of the relational model. So SQL. So one of the main reasons that the relational model is so powerful is that we're able to use SQL, structured query language. And this is a high-level language that is really easy to read, it's really easy to use. If you don't have a lot of background in programming, it is something that I think you can pick up pretty easily. So here's some sample SQL. So you can see we're inserting into the department, which is our table, and then these values. So it's pretty easy to understand what's going on here. We're just inserting into a table these values. You can also retrieve data from the department table, select all from department, and you can also see how many records are there. So it's a pretty useful language with working with data, and it's easy to learn, easy to pick up. So, and that's why it was developed. Edgar Codd originally, in his paper on the relational model, he really specified that he wanted a language to be created so that it could be easy to use for everybody. And he helped develop SQL with, he worked at IBM alongside Voice, and yeah, so it's used for all sorts of connecting tables, sending, retrieving data, updating, and deleting. So here are some relational database management systems that follow the relational model. To start off, we have Oracle database. And also real quick, has anybody ever used a relational database in a professional setting or project setting? If you used a database? Okay, so about 3 or 4 people raised up their hands. So Oracle database is known for its robust performance, scalability, and wide range of features. They offer a lot of, if you have like trouble with your Oracle database, they offer a lot of assistance. You have MySQL, which is a really popular open source. This is the one I've used the most when it comes to a relational database. It's renowned for its ease of use, reliability, and strong performance, particularly in web-based applications. There's also Microsoft SQL Server, there's PostgreSQL, there's IBM DB2, SQLite, MariaDB, which is a fork of MySQL, Amazon Aurora, SAP HANA, and Microsoft Access. And these are all relational database management systems. So you can use SQL to delete, update, select data from these database management systems. Okay. So now we're going to get into non-relational, NoSQL. And I know that can be a little confusing. NoSQL does not mean NoSQL. It just means not only SQL. So when we say non-relational, it is kind of a catch-all term. It's just everything that isn't relational. So things like the network model and things like the hierarchical model, or some other NoSQL databases that we'll get into later on, these are all just non-relational, just a catch-all term. And like I said, that doesn't mean that you can't use SQL. You can. It takes unstructured data. If you just want to throw everything in there, it takes it. If you want to semi-structure it, it takes it. And you can, obviously, you can use relational data inside a non-relational database. It's just, it doesn't matter. It's just there for taking whatever information you need to store. And it is really just the counterpart of relational databases. And the origins of these can be traced back to the early 2000s when companies like Google, Amazon, Twitter, Facebook, they were using these relational databases, and then they found out they weren't working as well with with a huge influx of reads and writes. Their databases just weren't really able to cut it. So they ended up, some of them shifted towards these non-relational databases to keep up with the influx of data. And then, so the main kinds of non-relational databases, you've got document, graph, wide table, and key value. And so with like a document, I'm sure a lot of you have seen JSON before. This is just a sample JSON document. And you can kind of see there is a semi-structure to it, right? So this is, for example, if you think back to my relational example, we have an employee, but we have like a whole bunch of extra information. So this can be easy if you have a bunch of attributes that you're continuously adding. Like you're not quite sure what the schema of your database or your table is going to be, so you can just add these in and it's fine. And so that is the sample JSON document.
Would you say that lends to mining and scraping then a lot?
I'm sorry, could you repeat the question?
With the no structure, the unknown structure, that lends itself to scraping and mining.
Right, so if it could be less secure, is that what like you're getting at? Yeah, you could easily scrape and mine, because if you query a non-SQL database, it might be returning a bunch of stuff that wasn't what you were looking for, but it's just querying it's just giving you back the document. So if it wasn't secure, you could be scraping and getting information that you weren't necessarily supposed to get. So this is Google Firebase Firestore. This is the NoSQL database that I've had the most experience with. I'm not sure if y'all can see that too well, but over here we have collections. So think of like a traditional file system. So I have my collection here. This would be like a folder. In this use case, I was using a web app for a clothing recommendation system. So part of that was we were taking in a bunch of clothing items and doing some algorithms with those. So these collections are just based off the user. So this is user, a bunch of characters, and then inside this user we have a bunch of different documents. And each document represents a piece of clothing. And then so we would query the collection for all the documents and then go through them. And so here are some other non-relational database management systems. MongoDB is a really popular one now. Apache Cassandra, Redis, Amazon Dynamo, DB, Couchbase, Neo4j, which is a graph database, Elasticsearch, React KV, Apache HBase, and like I said, Firestore. And a lot of these are fairly new. So there isn't, like for Firestore, there was not a ton of documentation, I'll be honest. But I think MongoDB is probably the most popular one, as we'll see. But like I said earlier, when it comes to non-relational databases, I mean, like Elasticsearch, like this is for search. Like when I first thought about non-relational database, Elasticsearch didn't come to mind. But using the term non-relational database, we can kind of throw Elasticsearch in there. And Elasticsearch is just it's just used for searching and analytic purposes. It's a distributed RESTful search engine. Okay, so part of my research was just kind of using these criteria and judging relational and non-relational databases against them. Originally, when I work on projects for school or just my own personal use, it always takes me a long time to figure out which database I want to use. It usually takes me 30 minutes, an hour. I never seem to be able to pick one just because there's so many. So it does help to narrow them down when it comes to relational and non-relational. That's going to take away a lot of them if you're able to narrow it down. So part of criteria, we got just going over the data model, structured, unstructured, preferred data size, small to medium for relational, and then large for non-relational. That's why they originally created to handle mainly large writes, as well as large reads. Here we have ACID. So this is ACID compliance, and it's just an acronym that stands for atomicity, consistency, isolation, durability. And here's ACID compliance. So non-relational databases are not ACID compliance. When we think about ACID compliance, it's very secure, it's consistent, you know what you're getting. Non-relational databases are not ACID compliant. So that is something to keep in mind when you're choosing a database. They aren't going to be as atomic, meaning the attributes are, each attribute can kind of contain multiple other attributes. When we talk about relational databases, that's you try to steer clear of that. And many of them make you steer clear from it. Consistency. It is going to be consistent in what is being stored in the database. Isolation, reliability. No, durability, sorry. And then we get to scalability. Relational databases are not as scalable as non-relational databases, as we'll see. Schema flexibility. Once you've set your schema for your relational database, it is really hard to change, and it becomes a huge pain to change. Whereas in a non-relational database, who cares? Just throw on some extra attributes, you're fine. So we got some others. The triangles just represent that it can vary, so it really just depends on the non-relational database. There are some that are really good at data integrity or really good for transactions, but not all of them. Some of them are terrible at it. It just really depends on what you're trying to go for. So you do have to get a little bit more involved when dealing with these criteria. Okay, so now NewSQL. So like I said, they are a subset of relational databases, but they are here to address those limitations from this previous table. So basically, wherever you see a check mark on this side, they're trying to bridge that gap between relational and non-relational. So we're talking about scalability, latency, while maintaining ACID compliance, while maintaining the relational model. So these databases are sold as really easy to scale, So if you do need some extra power, it's easy. So so we have CockroachDB, Google Spanner, NuoDB. So CockroachDB is actually 2 employees from Google Spanner went and did their own. So I think they are a little bit similar. I only have experience with CockroachDB, and it does act a lot like a relational database. It is a subset of relational databases, so it does work like them. It is really easy to introduce yourself to them if you have experience with relational databases.
Maybe they'll figure it'll live when nothing else will.
Well, so that's why they named it. Actually, I think I have it. So on this side, we have basically what they're doing with CockroachDB. So each cockroach here represents a node, and this is an instance of CockroachDB. If one fails, the data is going to be on each of these nodes. So if one node fails, it doesn't matter, because you have the data on these other 3 nodes, and they're constantly talking to each other to maintain the data, make sure it's consistent. And the same sort of idea. If you need extra space, you just add another node. And so if you squash one cockroach, it doesn't matter.
There's too many potential jokes.
So yeah, one thing I notice is you can come up with any word, slap DB on the end of it, and somebody's already got it. It doesn't matter. There are hundreds and hundreds of databases that are just random names. So here are the business cases. So complex transactions. So you'll sort of see that NewSQL databases try to get all the check marks from them. They try. And where you see those triangles, it varies. These are things that they are working on currently. These are really new databases. These are really new systems. There's not a lot of documentation. There's not a lot of support. So it is kind of hard to get check marks across the board. But they do end up being able to be highly scalable while maintaining ACID compliance, while maintaining being able to do complex transactions, and you can easily data warehouse them. You can use highly structured data. It's easy to read. That was the whole point. When NoSQL started to be introduced into the field, it's not as easy to just pick up as SQL, at least in my opinion. But yeah, so I'll leave that up for a couple more seconds. And most of the NewSQL databases follow that CockroachDB model of just, it's called sharding. So you just split up instances of that CockroachDB, and that helps with the scalability and performance.
Did you come up with that, or is that something you read in a published paper?
This was I made this.
Cool.
This is what I was working towards. Part of my research, I just wanted to see how I could develop a way to figure out a database to choose. And then I also just want to really quick go over like what professionals are using, what databases are currently being used. And so this is from the 2023 Stack Overflow survey, and they just asked professionals who were using Stack Overflow what database to use. Top one is Postgres, MySQL, SQLite, Microsoft SQL Server. These top 4, those are relational databases. They've been around much longer. There's much more documentation. It's hard to beat, especially when you're talking about business. You don't want to try something new and then it doesn't work. It's tried and true. But we do have MongoDB. It is coming up, and it hasn't been out that long. It has been out, but I wouldn't say definitely not as long as relational databases. And Redis and MongoDB. And as you'll notice, CockroachDB is not on there. But when we look at what people are learning, MongoDB jumps up very high. A lot of people are learning non-relational databases, and where is it? CockroachDB did make it. They made it. So it is getting more popular, and people are starting to use it. And then I also just wanted to touch up on multi-model. So a lot of relational databases have started just handling all sorts of data models. So relational databases have started taking in JSON. So the lines are really just being blurred as to if it is relational or non-relational, because they're currently changing to meet the standards of NewSQL databases. So they're like for Postgres, MySQL, you can store JSON in a data store. You can store those documents in a data store. That's perfectly fine.
Well, kind of like Visual Basic, you know, they try to do everything and they're no longer really around.
Yeah.
It sounds like that last category is going to be that way.
Yeah. So I do think NewSQL databases do have a place because, like you said, as you try to like throw everything together, it doesn't really work. You have to build from the ground up, like Google Spanner. Instead of trying to tack on new things, they were like, all right, well, let's start from the bottom. Yeah. In the future, I want to go over like every database and do like I did with the table, just go through every single maybe top 50 database and compare them. But I wanted to throw up my LinkedIn, my email, my website. You can always send me email, ask me questions, connect with me. That'd be great. Yeah.
Excellent.
I'll open it up to questions. Yeah.
I'm wondering, have you looked at sort of the secure queries from databases? And is there anything like this database allows easy, like private information retrieval kind of thing?
Yeah, so the question was, how can we think about like security when it comes to transactions in SQL and databases? I think relational databases are going to have NoSQL, non-relational databases, B, just because you're able to impose a lot of rules, a lot of constraints. For example, like cascading. You're able, if you want to delete something from a relational database, it has a lot of rules and constraints that you have to follow. That way you don't have like hanging records. It cascades, it deletes everything. Whereas in JSON, it's all kind of thrown in there. Who knows if everything got deleted? You'd have to check. So I would say relational databases are more secure than non-relational databases. I'm not too sure about NewSQL databases. I'm not sure how they're tackling security, but that is something to really consider.
One other thing about the new SQL databases, it seems like they're inspired a little bit by blockchain, where you have nodes and all the data.
Yeah, I think with, like, I know this is an overused term, but like cloud technology, everything's on the cloud. I think this is where we can actually see it being used. Like this is, for NewSQL, it is something that you're going to store on a bunch of different databases. They don't have to be all in the same building. They can be global. So I think that really contributes to like blockchain, cloud technology, something like that. You can draw a lot of similarities. Yeah.
So you'll have to forgive me. I am not familiar with CockroachDB or some of the other NewSQL applications. Are those proprietary? Are they free?
So CockroachDB, you can get it for free. You can download it and start using it. They also have for students. They have Cockroach University, which I started using, and it just runs through how to use it, how it's built. Yeah. So CockroachDB is I don't think it's open source, but you are able to use it. Students should have no problem being able to use it. Google Spanner is not. You're going to have to buy that, and I think mainly only Google uses Google Spanner because they built that specifically for Google, and they're incredibly weird use case that they have, right? Like not a lot of companies are like Google. Any other questions?
Thank God, thank you.
Yeah.
So as the lines get blurred more and more between relational databases and non-relational databases, do you think that the older, the more documented ones are going to be phased out in terms of the new SQL
I think so.
eventually?
This comes down to personal preference. SQL databases are just, when you're dealing with business, you need to make sure your data is what you think your data is. It needs to be consistent, secure, reliable. So I think businesses are going to start moving towards either NewSQL or some of these multimodal systems. And I think NoSQL databases will start to fall off. They're still really good for like social media, where like it's okay if 100 people like this post, but it only shows 99. Like that's not too big of a deal. Your data for social media platforms doesn't have to be 100% consistent. It just needs to be there, right? So like the latency, how fast you see a post, needs to be really, really, really small. It doesn't really matter if it's not 100% accurate. It just needs to be there, because otherwise you're going to lose users. So whereas most businesses will probably start moving towards or sticking with relational databases or subset NewSQL databases, there still might be a few social media platforms or companies who have a lot of data, but they don't really care about the data, if that makes sense. All right, thank you.